In many industrial processes, it is essential to know what the rate of reaction is between the reactants. If rate is too high, the system may overheat or may release the gas too quickly that could result in explosion. But if the reaction is too slow, it may not be economically viable. Many factors may affect the rate of a chemical reaction. These factors include concentration, surface area, catalyst including enzymes, temperature, and the pressure of gases. In this experiment, we will determine how the concentration of hydrochloric acid affects the rate of a chemical reaction. Various concentration of hydrochloric acid will be used with a calcium carbonate that is also said to be marble chips. Calcium carbonate reacts with hydrochloric acid, making salt, calcium chloride, and water, H2O, and carbon dioxide, CO2. Volume of gas released and the time will be followed in this experiment. For each concentration of hydrochloric acid, construct a table like this one and record your results. The gas syringe is very delicate. It is clamped gently. Check the barrel of the gas syringe. It can move freely. A piece of string is attached to the body of the barrel that prevents the barrel shooting out and breaking. The conical flask in which reaction occurs is also clamped gently. Make sure that the bung is good fit for the conical flask. Also ensure that the rubber bung have a suitable diameter to attach with the gas syringe. Using a measuring cylinder, measure out 50 cm³ of 2 mole per dm cube hydrochloric acid. To ensure you had exactly 50 cm³ of acid, you can use a pipette twice. And then measure 5 grams of marble chips into weighing board. Start the stopwatch. Record the result in the result table. Once you have obtained all the results, then the volume of carbon dioxide against the time is plotted. Experiment is then repeated with a different concentration of hydrochloric acid. For each concentration of hydrochloric acid should be plotted on the same piece of graph paper. This makes it easier to compare the results of versions of the graphs. We can see that with the lower concentration of hydrochloric acid, the reaction is slower. This is clear from the gradient of the curves of higher concentration of the acid. The curve is steeper. Steeper the curve, higher the rate of reaction, and vice versa. We can also see that in case of 2 mole per dm cube hydrochloric acid, reaction is finished in shorter time. This evidence shows that the reaction rate increases with increased concentration of hydrochloric acid. So the conclusion is consistent with the Killian theory consideration. Using more concentrated hydrochloric acid causes there be the more hydrochloric acid particles per unit time, which lead to more number of effective collision between the particle of HCl, hydrochloric acid, and metal carbonate per unit time. And the reaction is faster. That's all about this one. Thank you very much. Have a nice day.